So yeah, I'm Trevor Seifert. I'm a senior software engineer at SNC, and you know these last couple of years, I've been working or was working on the FARA program. We were the mission system integrator for the Bell 360 Invictus, and we were developing the mission system uh, in preparation for the competitive down select. So it was the Bell 360 Invictus, and we were competing against Sikorsky and the Raider X. In order to do that, we were really moving towards the OSVD event, the Open Systems Verification Demonstration event, which was a third-party evaluation of each of the competitors' mission systems. And so basically to do that, we had to develop a representative mission system using pretty much all face components, face UOCs. And we learned a lot during that time. We were kind of breaking a lot of new ground for building such a large integrated system with a lot of our own components, third-party components, GFI components. And while we were working on this, the GAO 2023 Weapon Systems Annual Assessment came out and noted that a lot of the surveyed major defense acquisition programs were still reporting a lot of challenges integrating MOSA systems and developing MOSA systems, and finding the sufficient resources and the documentation from contractors to integrate those systems. And we had an opportunity doing this very kind of on the ground floor early development of the system to experience and kind of quantify a lot of the problems that can come up during a large scale integration, and trying to find ways to mitigate that or kind of feed back into the standard potentially. And we wanted to share some of those findings for anybody else who's doing a large scale. This is really from the system integrator's perspective. So you might be developing some face conformant software. You might be integrating it into a larger system of systems. But there's a lot of lessons learned, and we're going to try to capture those in this short time, and a lot more of them are detailed in the white paper. An overview of the system: we had 6 third-party UOPs that we received either as GFI from the program or that we purchased to get a specific feature from a vendor who was an industry leader in a particular domain. We developed over 25 of our own UOPs. So we either ported some legacy software that we'd already developed for other programs, or we were developing brand new components that were in alignment with the requirements for the FARA mission system. We, at various points during our development, we integrated 2 different TSS segments, and we also had one OSS layer that we used for a number of the components too. The one big difference when you are the integrator of an open system is you get to dictate basically the target environment that everything gets ported into. So with the federated system, basically everybody's delivering you a complete LRU that works as a standalone device, and then you communicate with it over an ICD. Some software might get delivered as source code that you work into your environment, and in that case, you basically just recompile it for whatever your target platform is. But when you're integrating face UOCs, they're often delivered as a precompiled static library, because usually when there's a component that you're getting from a vendor, they've got a core intellectual property that they're trying to protect, and so it's delivered as a binary with some layer of that delivered as source code that you can use to integrate into your computing environment. And one immediate problem with that is that the UOP is only going to fit into your dictated computing environment, if it's compiled with a lot of the same parameters and against the same operating system and using the same version of the standard. Otherwise, you have to go back to the OEM for that software and have them recompile it. And we had to kind of do that a lot. And we didn't expect that up front. We basically got handed some GFI and said, go integrate this. And it's already done, so you should be able to just integrate it. And even if we're using the same operating system, even if it was compiled for Ubuntu and we were using Ubuntu in our test environment, there are still things that would happen that that would require us to go back to the original vendor and ask for them to recompile it with a couple of different things changed. There are a couple of things that cropped up more often than others. Often we would receive the development kits that included data model, included the static libraries, and included some shared headers, all the common face headers, whatever string and sequence that they would use, whatever injectable interfaces they would use. And every single time when we received a delivery, we expected we were going to encounter some build issues and tooling issues. Sometimes there was actually like an honest to goodness implementation error, like one of the interfaces was wrong because the vendor misunderstood one of the interfaces, or maybe that hadn't been exercised before and we were exercising it in a different way. Sometimes there was nothing wrong. It was just that maybe they were on a different version of like some approved corrections that we had applied and they hadn't, or vice versa. But there was always some kind of subtle compilation error that would happen. So we'd spend a while just going back and forth trying to get it to compile, and we needed a lot of input from the OEM. And you can understand a lot from the data model itself, and you can get a lot of the semantics from what the messages are supposed to be, but that doesn't tell you nearly everything you need to know in order to kind of exercise the software. Typically, an ICD is going to tell you a lot more about how often you should send that message, the back and forth, if any kind of a handshake has to happen, the nature of that data, any error messages that might happen, what happens when that data is wrong. And in the long run, we realize we're really sharing more data between the integrator and the vendor than if you're just doing a federated LRU or a federated third-party software component. Not only are you sharing native documentation that you would normally have, like a software user manual, then you have to have all the face shared data model, and you have to have a little more information about exactly how that injectable interface is supposed to be instantiated. Otherwise, the software is just going to segfault, and you really have no idea why. So here's some other things that would happen. There's a number of things that would pop up and cause that incompatibility when we were dealing with third-party components. One example is that the data model types and the attributes were named the same. So for example, like we would have one type and it was named the same as a type that we brought in, and the compiler would fail to distinguish between them and complain that something was redefined, or maybe there was two of the same types in the data model, and the data model would think it was fine, but sometimes the generated code would generate the same type twice. We would sometimes get UOPs that maybe they were only tested against a single TSS. Now, not everybody has access to every TSS that's out there. And so they're used to either working with a third-party one that they have a license for, or they have a proprietary TSS that they've built, or they've just used the Balsa TSS because that one's free and easy to get access to. But not every TSS is the same, and even though their API is the same and they use the same bindings if you're using the same programming language, the actual usage of the interface of the TSS is not going to be the same. So some TSSs require that you instantiate just one TSS base. Sometimes every single one of your type TSS is a TSS base. So you actually need to have that UOP come in, be aware of the number of like TSS injectables that it's going to have. Sometimes you actually have to register more than one TSS base And a lot of UOPs don't expect that to happen because I'd say the majority of TSSs are a monolith where you kind of have a single TSS base and then you make a bunch of type TSs, but that's not necessarily always the case. So really all these kind of sound like normal integration problems you would have a third-party software. So even though a lot of the interfaces are dictated for us in FACE, we still face a lot of the same challenges that you would face with federated integration. One of the other issues to be aware of is there are some headers and classes in the FACE standard that there might be more than one way to use them. So both the vendor and the integrator can be correct, but there are still some underlying programming constructs and rules that you could violate if you don't approach it with care, such as string and sequence. I think a lot of people are already aware of this one, but if you have to define the string and sequence classes so that you can use those particular data types, and I'm talking specifically with the C++ definitions of these types. Typically, we'd have our own string and sequence definitions that we wrote, and we liked them and thought they were good. But then another vendor who is, giving us their version also has their string and sequence that they've defined, and it works well for them. But then when they compiled their static library, they would send it over to us, and their software was compiled with one definition, so one size of the header of the string and sequence, so it would actually allocate potentially more or less memory than ours might allocate because the definitions are the same, because we violated the one definition rule in C++ where there should really only be one definition of a particular class. So once we realized this would happen, we would basically just give all our vendors an SDK saying, please use our versions of these headers. All you need is the header. You don't have to compile it with our definition. This is something that's actually in the process of being fixed in the consortium. We're switching over to a Pimple implementation, so that it is just going to be a pointer of the implementation. All the headers are going to be the same, and this should alleviate the problems of having the one definition rule violated. Another example of this issue is, like I just said, one TSS may be required to be instantiated multiple times for each message sent, but another TSS might require just one instance of itself. Like you might just instantiate it once in the main, and if you just hand out that exact same instance to every single UOP, sometimes you might have to instantiate one per UOP. All of them are different. So you have to kind of agree on the schema of the TSS base, and when a UOP did not expect this to work that way, we either have to modify the actual injection code, or we had to write a wrapper around it so we could handle the picking which correct TSS to send to the individual UOP. So we found that the best way to alleviate a lot of these problems, once we learned more and once we got some more experience under our belt, is that really it comes down to, as the integrator, you have to be the final say, and you have to heed a lot of these problems off by imposing specific requirements to the vendors of the UOPs that you're going to get. And if you are very clear in your guidance of how to instantiate these and which TSSs you expect to use and whose string and sequence you're going to use and which proof corrections that you are going to apply before you get the software delivery, you can avoid a lot of these issues that happen when you tend to integrate a third-party component. So before you have them under contract, or if you have the ability to work directly with the supplier of the GFI component, in this case we did, the component wasn't like a final product that just was delivered and then the contract was done. Thankfully, the government still had them under contract to give some support for this particular program. We were able to work with them and fix some of the issues with that. And all of these are basically dictated in addition to normal contractual requirements. You can include these in your integration requirements and things like the target version of the technical standard, whose headers you're going to use, things like that. The full list of this is included in the white paper of the things that we included in our face. We called it our face integration guide that we distributed out. We also got a good idea of what the quote unquote best way is to have a third-party component delivered to us. And whenever we were working with a new vendor for a particular component that was going in the mission system, we had to kind of make a call about which of the two options was going to be better. And this first option is to wrap the component coming from the vendor in basically all our own face porting layer. So that means the software that you're going to get from this vendor, you actually don't have them deliver you a UOC that has no intention of face conformance. You're just getting their legacy API, their legacy deliverable compiled for whatever your operating system is and your compiler and whatever settings that you want. And then the integrator actually performs the face integration and actually adding in the injectable interfaces, TSS, making sure that it uses just the OSS allowed interfaces. And this is really good if you're working with a vendor that really has no experience at all with doing development to the face technical standard. And it's not ideal when you have to go down this route, but sometimes if you're pushing up on a deadline, or you just as the integrator, you're probably going to know more than your vendor. That's not always true, but often, especially when you're deep into mission system development and doing a large system of systems, you'll know quite a bit. And you can kind of make the call saying, just focus on doing what your software does best, and we will handle the face side. So it's more work and more time and more risk taken up on the integrator side, but it can avoid some problems with having to kind of sort out some of the more hairball issues that can come up. But even better than that, if you can swing it, is to have it delivered as a static library and having a very clear kind of division of what you're going to get. So you can see here in the teal box on the left, the recommended exposed interface. So the vendor still gets to keep their business logic, what actually makes their software tick and what makes their money. They can keep that closed off. They just compile it against whatever computing environment requirements that you give them, and even they can write the porting layer between the TSS types and their own business API, and they can do all that, and then they just provide you basically the layers of, you get to write your own initialization functions, you get to write your own injectable interfaces. Like they just give you the headers, and you actually implement the injection calls, and that really gives you a lot of flexibility into if you need to inject more than one TSS base, for example, if you have a very unique way of setting up your config objects and things like that. And that way you get just enough flexibility where you can adapt it to your own potential computing environment, but the vendor gets to keep all of their intellectual property safe. It still requires a lot of communication with the vendor. You can't just have them drop it in your lap and then fly up into the sunset. You still really need to do a lot of communication, and just make sure you plan for that when you're setting up a contract with the vendor of the software. The last problem I'll talk about is when you're the integrator and you are responsible for dealing with multiple data models. It can be very challenging to deal with large models that are kind of a conglomerate of all the models that you get. And the reason why this is unique to the integrator is because when you are the developer of a single UOP, you're just really going to make one data model. You're going to make one USM, and you're going to use the CTS to verify that model is correct. You're going to make sure that it generates whatever type TS interfaces that you get. But when you are the integrator, you need to have that model integrate and basically combine it with all your other models. Because let's say you have a UOP that needs to talk to somebody else's UOP that you're getting, your data model has to have both of those UOPs existing, because you need to generate your ports and your connections that communicate those different data types back and forth between two UOPs. So they all need to exist in the same place, and really ideally in the one large mega model for your integrated system. And that turns out to be a lot more difficult than you might think. And because everybody's going to build their models in a different way, they might use different SDMs. We had to use a very large DSDM from the FVL architecture framework, and sometimes vendors would even tweak the SDM, which is not allowed. You're not supposed to make any changes to it, but sometimes like, well, we're not ready to move the SDM to a newer version. Let's just add in a couple of those elements that were missing from the newer version. So we would slap the wrist for that if that ever happened. But it did happen actually more often than you might think. And so we really had to kind of enforce which SDM we wanted to use. And then some people were saying, oh, the person who built our data model isn't around anymore, so we have to go back and figure out how to roll it to a new SDM. And what really happened is that when we would put them all into the same model, we got all sorts of incompatibilities, and sometimes things people would name UOP as the same thing, like they'd use a default name. I have a big list of some of the other more detailed issues that we ran into, but it's a problem that you're definitely going to need to spend some time on and have somebody who really, really deeply understands the modeling language in order to resolve some of those issues and make sure that it all goes into your modeling tool correctly, and you can start generating your type TSs with whatever your TSS tool is. The other problem is working with a DSDM. DSDMs are very useful. We got a very, very large one. It's the FVL, the aviation DSDM, and it had thousands of elements in it. And a lot of those were really useful in first understanding what kind of the data types are and the concepts are in this domain. However, working with a DSDM can increase the time it takes to do a model, because not only are you having to use common types, you have to make sure you're using the right ones, because if you have a DSDM that is huge, the whole point of a DSDM is that everybody's going to be working for the same conceptual entities, and that way, when one person's talking about some kind of track and another person's talking about a track, you're making sure you're talking about the same concept of a track that's sensed by a particular sensor or something like that. But if two modelers look at this DSDM and are trying to describe the same thing but end up picking a different entity in that DSDM, then that means the DSDM is not clear enough, because you're supposed to have like a very clear common syntax and semantics between those two elements. So it became this very big hunt and debate of searching. Oh, I need to describe this one particular field in my message. Which one should I use? I have to go through this huge needle in a haystack to try to find a particular element, and no two modelers would really do the same thing. So we noticed that there's kind of diminishing returns in working with the DSDM. So it's important that when you are working with a vendor, if you can, have them start from the same DSDM that you're working with. That's another big thing, is that if the model that you are ingesting does not use the same DSDM as you're using, are you going to go and basically change the entire conceptual and logical layer of the model? That's a ton of work, and it can run into a lot of problems. Or are you just going to quarantine it and just kind of have it not follow your practices, at least for the time being? So you got to make those kind of decisions. There's a lot of other little nuances, and I suggest you read through them in the white paper if you're interested to hear more. So that was a very, very quick run through of some of the things that we found. It was when we were developing all these software components for the mission system for the 360 Invictus. It was a brand new design. We had a lot of a lot of requirements for all these components, but all these components are typically components that already exist in other platforms. When you're dealing with subcontractors, not everybody is going to be as MOSA and face savvy as you are. As the integrator, you're probably going to be the best. You're probably going to be the smartest in the room when it comes to talking to a lot of vendors, depending on who you're talking to. There are some people who talk to who have been in the consortium for years, even longer than us. And it became pretty quickly apparent, that we were definitely dealing with an expert, and we did a lot of listening instead of talking in that case, to try to kind of improve our knowledge. But if you're not, don't panic. There are options you can do that you can use to mitigate a lot of the some of the integration things that can come up. And as we do these, I think it's important that when we have systems that start to feel that are these integrated systems, FLARA is one example. Is going to be one of the hugest, most MOSA from the ground up systems that has been out there so far. And the future owner of this system is going to have to think of a lot of these things when they want to make a some kind of upgrade. But the more teams, the more you build up that foundation of open system knowledge and understand a lot of these trade-offs. And if your team understands a lot of these trade-offs, then one thing we found is that it did ultimately lower integration time once we understood these things, and once we were working with vendors who had very clear definitions and boundaries for creating their UOPs. Eventually we did finally see the benefits of using this, using these open standards. It just requires a lot of upfront work. It's not just going to magically just make all the integration easy. You still got to go through your normal software development process, I guess, is the kind of the takeaway from this. So yeah, that's the end of the slides I have here. It was really interesting working on this program. I'm sad that it ended because it was a huge opportunity, I think, to bring up that there are still other platforms that are out there. If there's anybody from our competitors at Sikorsky and Lockheed on the call, I'm curious to hear if you had some of the same experiences on this program and some of the same lesson learned. And I'd like to talk about those at some point if you ever find me at a convention. So thanks for listening in, and I'll open it up to questions if we have time.